Hi, this is Ratan Gupta from Knowledge Varsity, and here I am discussing a problem related to Bayes theorem. This problem came in FRM 2010 sample paper. Okay. As you know, Bayes theorem is part of quantitative methods. Let's see the problem and understand that how we can attack this problem. The problem says that in a country there is the probability that a letter sent through the postal system reaches the destination is 2 by 3. That means only 2 out of 3 letters reaches the destination, and they are saying that assume each delivery is independent of the other delivery. Another assumption is if a wife receives letter from her husband, she will definitely respond to her husband's letter. Suppose a man in the country mails a letter to his wife. So a man sends a letter to his wife. Wife stays in the same country through the postal system. Now, what they are saying is if the man does not receive a response letter from his wife, so the man is not receiving response letter from his wife, what is the probability that the wife received the letter? Okay, so here they are saying that the man did not receive a response. Given that man did not receive response, find out the probability that wife received his letter. Okay, so this is a typical Bayes problem. However, here you do not have access to the tree diagram, so you need to create the tree diagram on your own. Now let us try to find out how to draw this tree diagram. Please note that the tree diagram has two parts. Okay, this right part and this is left part. So this is your left part and this is your right part. So what we will say is this right part can be created, from whatever is given. So this right part is already given to you in the problem. So it says that given that man did not receive response, so your right part's node will be having like man receiving response and man not receiving response, man receiving response and man not receiving response. Okay, right? So whatever is given, that will be in your right part. Okay, and they are saying that what is the probability that his wife received the letter. So the probability that his wife received the letter, that should be on the left part. So left part should be what is to be found out. So whatever we have to find out, it will be in the left part. So please note that the left part should have whatever we are finding. Okay, so right part should be given and left part should be finding. So here let us try to understand this structure. Okay, so when the man sends a letter to his wife, so the wife receives the letter given by probability of 2 by 3, and wife is not receiving the letter given by probability of 1 by 3. So 2 by 3 and 1 by 3. Now when wife receives the letter, it is said that definitely she will respond. So she will respond to the letter. So let's say she responds with probability of 1. She responds and then man gets the letter. Again, since he is on the same delivery network, so the probability that man receives the letter is 2 by 3 and man does not receive the letter is 1 by 3. Now this creates much more complex kind, because this probability is 1. Why can't we do this? We can get away with this probability equal to 1. So what we'll do is we'll get away with this and just replace this with 2 by 3 and 1 by 3. Okay, so what we have is the man is receiving the response letter from the wife with probability 2 by 3, not receiving the response letter with probability of 1 by 3. Now when the wife does not receive the letter, she will definitely not be able to respond. So probability she is not responding is 1, and when she is not responding, husband is not going to get. So the probability that men will get back the response will be 0, and probability that man will not get the response is 1. So this has created our structure. Okay, now let us see what is being asked in the question. The question says that the man does not receive response. So we have to find out which are the nodes where the man is not receiving the response. So what I will do is I will number the nodes over here. So this is my node 1, this is my node 2, this is node 3, and this is node 4. So man is not receiving the letter in node 2 and node 4. So in node 2 and node 4 he is not receiving the response. Okay, so what they are saying is, given that he is not receiving the response, so either he is in node 2 or he is in node 4, we need to find out what is the probability that wife received the letter. So when is the wife receiving the letter? The wife is receiving the letter here, which is a part of node 2. So node 2 is where the wife is receiving the letter. Okay, now what I will do is, I will, rather than solving it through the Bayes theorem formula, I will solve it from the standard probability concept. So the probability is given as your favorable case divided by total case. So here my favorable case is where the wife is receiving the letter. So my favorable case is node 2 and my total case is node 2 plus node 4. So when we are saying that node 2 plus node 4, we need to add the probability. So what I will say is, the probability is given as probability of node 2 divided by probability of node 2 plus probability of node 4. Now what is the probability of node 2? So from this diagram we can find out the probability of node 2 would be given as 2 by 3 into 1 by 3 is just a cross multiplication of this path and this path. So it will be 2 by 3 into 1 by 3 divided by probability of node 2, it will remain the same, 2 by 3 into 1 by 3. And what is the probability of node 4? Node 4 probability will be this into this. So the probability of node 4 will be the joint probability of this path and this path, which is 1 by 3 into 1. Right? So this becomes 2 by 9 divided by 2 by 9 plus 1 by 3. 1 by 3 can also be written as 3 by 9, just multiplying 3 and 3 on both the side. So this will become 2 divided by 5. So because 9 will get cancelled and this is 5 by 9 in the denominator. So the probability, updated probability of men not receive, wife receiving the letter, given that men has not received the letter, is 2 by 5. So we'll see that this is option number D. Right? So this is the way you should attack a Bayes theorem problem. Okay. Thanks. This is Ratan Gupta from Knowledge Varsity.